All right, so this is we're going to be covering questions 1, 2, and 3 on this worksheet. So this is the I do part here. So as the teacher, I'm going to go through these, and then you have 4 examples to practice with. There'll be an answer key for all of these, so you'll be able to check your work as you go through it. Let's go ahead and start with this first one. It says there's a group of 125 pickup truck owners. They were asked what brand truck they owned and whether it had a 4-wheel drive. Here's the 2A table with the results. Okay, so you randomly select one truck owner. What's the probability he owns a Dodge or has 4-wheel drive? So we write this up in symbols. We have 4-wheel drive, or with the union symbol. Let me draw that a little bit better. So or Dodge. So D for Dodge. All right, so 4-wheel drive is this yes column. Dodge is this bottom column here. So using the rule, addition rule, we can add these two and subtract the center. So it's 80 plus 30, subtract 20. Or we can just add up these 4 spaces here. What we're going to end up with, though, is 90 out of 125. Okay. Now this answer is actually would simplify to 18 out of 25, but we don't see that on here. Okay, so we're really just going to go with D for this one. Next, you randomly select one truck owner. What is the probability that he owns a Chevy given that, okay, he has 4-wheel drive? Okay, so we have a given condition. So 2 here, we want to make sure that we write this up. Probability. We know given that, so we have this line here, given that they have 4-wheel drive, what's the probability that they own a Chevy? So C for Chevy here. Okay. So we know that we need to use our formula, so we write probability of Chevy or and, so intersection 4-wheel drive, over the probability of, we have that, the one that's on the right is the one that goes in the bottom in the denominator, so 4-wheel drive. Okay, so now we're looking for the intersection Chevy and 4-wheel drive. So there's 32 people have Chevy and 4-wheel drive. Okay, so that's right here, that intersection where I circled. Next, what's the problem? How many people have the 4-wheel drive? Well, 80. So this is 32 out of 80 on here, and that gives us our answer B. Okay, so this last one here that we want to look at is going to be very important for your test that you're going to be taking soon. So you randomly select one truck owner. Which of the following is true about the events? Owner has a Chevy and owner's truck has 4-wheel drive. So we're talking about this. It says mutually exclusive and independence. That's what we're trying to decide. Okay, now first off, the word mutually exclusive means they can't occur together. That means if we had mutually exclusive events, we'd have zeros inside of these intersections. So we don't have any zeros. So the first thing we want to talk about mutually exclusive is the idea, okay, mutually exclusive, well, these can occur together, so they are not mutually exclusive. So it can't be A and it can't be B on this one because they have intersections. So that can be the first starting point for a lot of these questions. You'll see you'll have this question repeated several times here on 9 down here. You don't have multiple choice, but you'll write it out. Okay, here you have multiple choice on 6. Let's go ahead and let's talk about independence. So this is from our notes here, and this is what we want right here. This is how we show or prove independence. So 2 events A and B are independent if the occurrence of one event does not change the probability of the other. So there's a couple ways that we can think through this. First off, we said that events that are mutually exclusive are never independent. Okay? Because knowing the outcome of one determines the other. So that rule doesn't work the other way. Because we know they're not mutually exclusive doesn't make them independent. We still have to prove it. So let's talk about how we prove that. For number 3, we have to use these rules here. Okay, and I only have to pick one of them. It doesn't really matter which one. So we're going to go with with one of those there. So I'm going to do probability of Chevy given that four-wheel drive is equal to, we want probability of Chevy, right? That's kind of what we're trying to do. We're trying to show that just because we know that they're four-wheel drive shouldn't change the probability of getting a Chevy. So we already did this left side of this equation for number 2. So we're going to go ahead and write that 32 over 80. And now we're trying to show that that's equal to probability of owning a Chevy, which is 32 out of 125. Well, actually, sorry, 50 out of 125. There's 50 Chevy owners out of 125. So 50 out of 125. Okay, so now let's just convert these to decimals to see if that's going to work. 32 divided by 80. That's 0.4 on the left. What's on the right side? Let's see. So we have 50 out of 125. There we go, 0.4. So this means that they are independent because those probabilities are the same. This means just because this event here is happening does not actually change the probability of this. So we will say they are not mutually exclusive, but they are independent. So C is the best answer on that. So the rest of these questions here are practice problems for you to work on using this rule. You didn't get a lot of practice with it in the problem set, so you'll want to try these out on your own. Of course, I'm going to put a answer key at the bottom of this, like the last page of this worksheet for you all to answer these questions. So there's plenty of examples here for you to do. Use what you need from this. This is just to help you guys out, okay? Next, let's go on to probability modeling here. I'm going to be working this question. So you have a standard deck of playing cards that you'll be using here. So AP students, you'll looking at this question, and we'll talk AP and we'll talk dual credit. So we have a standard deck of playing cards. Now, knowing there's no jokers in it, but you guys understanding the composition of a deck of playing cards is pretty much part of the curriculum here for AP students. For dual credit students, of course, you have this on the back of your formula sheet, so you have that available if you need it to remember all the different parts of a deck of cards. So it even explains what the composition is to you in the problem, so that should help. So here we go. It says the Jack, Queen, and King are referred to as face cards. Imagine that we shuffle the deck thoroughly and deal one card. Let's define the events F as getting a face card and H as getting a heart. So we have two events here. It says make a two-way table. That's number 1 here. So we're going to do that. So I'm going to make myself a simple two-way table. So I'm going to put F on the left for face card and then F complement for not face card. At this point, we should have a lot of experience with creating these two-way tables. So we have H, not H. Okay. So with this one, a lot of these we've been doing percents and such, but we're going to make sure we do counts for this. It's going to help us out quite a bit. Because how many cards are in the deck? Well, there's 52, so we're going to put a total of 52 in here. Okay, now we want to fill in the rest of this. So the first thing is, how many total face cards are there? Well, if you can't do that in your head, of course we can go here. It already said that King, Queen, and Jack are all face cards. So how many are there? Well, there's 12, right? 3 rows of 4 on there. So that's one way that you can use that. So there's 12 of these. That means there has to be 40 that are not face cards, right? Then H is hearts. Again, I can go to my table here if you don't know it. How many are in the suit for hearts? Well, if you count them, there's 13. It even tells you right here each suit has 13 cards in it. So we put 13 hearts. That means that there are 39 that are not hearts. Okay. Now I just need to fill in the rest of this. How many face cards are hearts? Over here, face cards that are hearts, well, there's 3, right? King, Queen, and Jack. So we put 3 here. Now we can fill in the rest of this without even doing any sort of thinking. That's the main parts that we needed. So we needed 10 and 30. All right, so number 1 is done. Now, find the probability of a face card or a heart. So this just goes back to that rule that we're looking face card or heart. So that's 25 minus 3, the intersection here, or you just add these 3 up. There's several ways that you can do it, but it should be, looks like 22 out of 52. Now, of course, if we wanted to, we can simplify that to 11 out of 26. If you want to put it as a decimal, you can do that as well. It just depends on what the multiple choice is asking for. Here, we don't have multiple choice, so you know, we're not interested in that. Okay. Next, it says find the probability of not C or not H. So not a face card and not a heart, or not a heart. So we still have the or statement. We're going to do the same thing, except we're using the complement parts. Okay, so we want these 3 spaces here. So it's not a face card is 40, not a heart is 39. Subtract the intersection, but let's just add these. That's kind of the best way to do it. That's how I like to do it. A lot of students that I've seen face to face really enjoy using this rule here. It is this one here, A or B, if they're not mutually exclusive. AP students, you guys don't get this, so let me pull up what you guys have just to make sure that we're clear on what formulas you have available to you. Here's AP. Oh, you do get that one. You have the or one, so you only get these 2. You get the conditional probability, but you do get that one as well, so you can use that formula. Okay, so anyway, back to this. We know it's these 3 added, so it's going to be 49 out of 52. Also, this is just everything except this space here. So just 52, take away the 3, and you get what's left. 49 out of 52. I don't think we can divide that by a common factor. I think that's going to be the answer to this one. That's going to be the goal for this. We've got a lot of really cool problems here for you to try. More playing cards trying to set up. Here we have red card and jacks. So that's an interesting 2-way table to try out on your own. And then we have this roulette wheel. That's pretty interesting. Okay, so give those a shot. Move to this final page here where we have, we're going to talk about tree diagrams. Okay, so let's go ahead and talk about these situations. This will be the last problem that I show, and then you're going to work the rest of them. In a recent month, 88% of automobile drivers filled their vehicles with regular gasoline. 2% got mid-grade, and 10% bought premium. 18 of those. That's a typo. Let me fix that. Off the draw tool. Of those who bought regular gas, that's what it's supposed to say. Sorry. Of those who bought regular gas, 28% paid with a credit card. Of customers who bought mid-grade premium gas, 34 and 42% respectively paid with credit card. Suppose we select a customer at random. So we want to make a tree diagram. And when you're building a tree diagram, I want to figure out what event is happening first, okay, or multiple events, which it looks like we have multiple events happening first, okay? The first thing that's happening is they're going to purchase the gasoline type. And there's 3 different types, so a 2-branch chart is not going to work. We want to have more branches, so we want 3 branches here. I'll do this. For the 3 events, we have regular, mid-grade, and premium. So I want R, mid-grade, and premium. Okay, from there, then they're going to either pay with a credit card or they're not going to pay with a credit card. Okay, so we're going to put from each one of these, we have credit card. I'll just put C and not credit card. For each one. Okay, there we go. So that's our 2-way table. Next, so we almost have our tree diagram finished. We just need to put the percents on here. We said 88%, so I'm going to put 0.88. It is usually better to put decimals on these. It's going to be easier for calculation. So 88%, 2% got mid-grade, and then we have 28%. Wait. 10%. 0.1 for premium. Okay, next. Of those who bought regular, 28% paid with credit card. So here's regular, 28% paid with credit card. Next, or we can fill in this bottom one here by doing the complement, because that's just got to be what's left here. So that's 72. Next, 34% bought mid-grade with a credit card. So that's 34. Which means this is 0.66. There we go. And then the last one is 42%, so 0.42. And that means that the bottom is going to be 0.58. Okay, so we've got our tree diagram done. 13 is finished here. Okay. Next, find the probability the customer paid with a credit card. So that means everywhere that there is a C, so here, here, and here, I need to add all those together. So we start by doing the multiplication. That's 0.2464, and I want to write out all those. Okay, now I'm going to do the next one. 2% times 4%, 0.08. Okay. Then the last one is going to be 0.1 times 0.42. All right, so now let's add these together. So we want 2464, 8. So there's our answer that we want for this, 2952. So 0.2952 is going to be the probability that they're going to pay with a credit card. That's just all from all the people that are buying gas. That's going to be their probabilities. Okay, given that the customer paid with a credit card, find the probability that she, or he, I guess, bought premium gas. So given that the customer paid with a credit card, so we're going to write this up. Probability, given that they paid with a credit card, what's the probability that they bought premium gas? Okay. So we're going to write up our formula. Again, AP, you have this formula right here, your conditional dual credit. You do not. So this is probability of premium and credit card over probability of a credit card. Now, luckily, we already found the probability of a credit card. So we have this bottom value, which is 0.2952. Okay. And then the top one is the intersection. That's where both occur. So that's premium and credit card, which we already found that as well. So it's this one right here, that 0.042. Okay. So we're just going to divide those, and that should get us our answer. So 2 divided by 0.2952. Put that in right. We'll round to 4 places generally on these, so that's going to be, get that, or drew that 2. Let's look at that again. 1423, it looks like. There we go. So that's our answer for these questions. And the next question, it's the same thing. You're setting up a tree diagram. Really, all of these, you want to do that. I do need to change this one here. So this one is create. That's all you need to do on that one. Okay. But 19 is one of the ones with the diseases, the false positives, false negatives. So that's an important one to practice. But we're going to go ahead and stop there. If you have any questions, reach out to me. There'll also be an answer key for all of these that I did not touch on.